Let's talk about distance travel. As you can see here, distance travel, it's represented by the symbol d, and there's no right arrow sign on top, so it means by this is not a vector quantity, it is a scalar quantity. So we know it's a scalar quantity, that means it only has magnitude, it has no direction involved. Okay, so we say distance travel is the length of actual path. So if we use back our previous example where we start with a person standing at the origin, then run towards the right, towards x equals to 4, make a U-turn, then walk or run for another 11 meters towards the left until you reach the point x equals to -7. So this is the example that we have been using for the few videos earlier. And if you try to determine the distance traveled for this example over here, we have to add up all the path. Okay, we add all the length of the path that has been traveled by this person. So we need to add up this portion of the length, you add up this portion of the length, and this portion of the length. Okay, so if we do it from t0 to t3, which is what I said just now, what we do is we add up the first portion of the journey from the origin to x equals to 4, the second portion of the journey from x equals to 4 back to origin, and the third portion of the journey from the origin to x equals to -7. Okay, and as you can see here, even though the first portion of the journey is towards the right, whereas the second portion and the third portion of the journey is towards the left, but we don't care about this because as we see just now, direction is irrelevant in our discussion over here. So even though they have different direction, you can just add them up, because what am I adding up here are all scalar quantities. So I'm just adding up the magnitude. I have no direction involved over here. Okay, so we know here is 4 meter, here is 4 meter, here is another 7 meter. Again, no positive, no negative involved. We just talk about length. There's no direction involved. So add up everything, you get 50 meters. Okay, so that's it. That's distance travel actually. Okay, so if you want to make a little comparison between distance and displacement, the first thing that we know is distance is a scalar quantity, displacement is a vector quantity. As you can see here, there's no right arrow sign on top, so this is a scalar quantity. If you go to displacement, there's a right arrow on top, so this is a vector quantity. Okay, the next thing that we know is distance is dependent on the path between 2 points, whereas displacement is independent on the path between 2 points. So what does this mean? Okay, path, or we usually call it as journey. Okay, so for this example that we said just now, the path will be what I draw using the red dotted line. So this is the path tracing towards x equals to 4, go back to x equals to 0, and then goes to x equals to -7. That is the path. And as you can see here, in order to obtain a total distance travel, we need to know how we travel. We need to know we go from here to here, then turn and go back until here. We need to know the path in order to obtain distance travel. But if you look at displacement, for displacement here, I totally ignore the fact that I need to make a U-turn at x equals to 4 in order to run back towards x equals to -7. I totally ignore the fact that I travel this way first before going this way. I throw it off from the diagram here. And if you look at the calculation here, I only care about where am I at time equals to 3 and where am I when at t0. Okay, I only care about where am I at this moment and where am I at this moment. Then I just take the position at the later moment, or the final position, minus the position at earlier moment, which is the initial position. Then I get my answer, then I transfer it back to vector. Okay, there's no path involved in my whole calculation, and I don't even care how I get from my initial position to my final position. If I don't care, that means it's independent. It's not dependent on the path. Therefore, we say displacement is independent on the path between the 2 points. Okay, so let's now try to analyze what are the meanings for the sign and the absolute values for distance. Okay, distance travel is again d. So there's no x component of something involved over here. It's just distance because it's a scalar quantity. There's no direction, nothing to resolve. Okay, so what happens if the sign over here it's positive? What does it mean? Well, it doesn't really carry much meaning, okay, because it must be positive. Okay, for a scalar quantity, this is a scalar quantity and it represents length, right? Distance traveled represents the length of the path traveled. So if it's a length, right, there's no negative length. Okay, negative length doesn't carry any meaning. Okay, when we talk about displacement, the negative, the component negative, it means it's pointing to a negative x direction, right? But when we say we don't care about direction, then negative length doesn't carry any meaning anymore. Okay, why do we need negative length? No, there's no need to have negative length. That's why distance travel is always a positive value. Okay, so you can't have negative value for distance travel. It's length. Okay, so there's no negative length, so you can remove the negative part. Okay, then you move on to the absolute value. So the absolute value, it's increasing with time. What does it mean? When it's decreasing with time, what does it mean? If you think about it, as time increases, can you have length of path getting shorter or not? Okay, when your time goes on and on, can you have shorter and shorter distance traveled? Well, that's illogical, right, actually. The only way for you to shorten the length of the path that you travel is to go back in time, actually. If I have walked for 5 meters, am I able to reduce the 5 meters that I have walked? No, those are in the past already. Okay, so your length of path traveled can only accumulate. You can only get more and more distance traveled if you continue to walk. There's no way, there's no method available for you to reduce the distance traveled by walking. Okay, you walk in the opposite direction, you are also gaining length of the path traveled. You cannot reduce it. Okay, in this case, we say that it can only increase with time. So decreasing with time, it's impossible as well. But if it's increasing with time, what does it mean? It means you are moving. Okay, if it remains constant, if the distance traveled remain constant with time, it means that you are not moving. So let's say you have walked for 8 meters. If the 8 meter continue increase to 9, 10, 11, it means you're walking for another 1 meter, 2 meter, 3 meter. But if your distance travel is 8 meter and 5 seconds later it's also 8 meter, it means you are staying there, not moving. Okay, so increasing with time, it means your the object or the person there is moving. Okay, so that's how we give meanings to the various parts. I mean, most of them can't, it's not relevant for distance travel. But yeah, that's it. That's what we know about distance travel.